Hi, everyone. So today we are going to focus on solving absolute value inequalities. Our learning objectives are the following. We'll be able to solve absolute value equations. We'll be able to solve absolute value inequalities with less than and then with greater than. And we'll use the tools and strategies that we've learned in the previous section and then add on to them as well. So let's jump into it. We'll start off with a warm-up problem dealing with our good old order of operations, and then utilizing also our absolute value function. So first off, what is the formal definition of absolute value? It's simply the distance away from zero. And then one thing to point out is that distance is always, always positive. So I've put a nice example down below here. If we were asked to find the absolute value of -5, that's just simply 5. But also the absolute value of +5 is 5 because what we're simply doing is we're figuring out how many units away is -5 from 0 and how many units away is +5 from 0. They're both the same exact amount. They're both 5 away. Okay, so now knowing this, let's just jump into our PEMDAS. Another thing that you should note is that even though absolute value has that definition attached to it, it is also representing a grouping of numbers or a grouping of expressions. So the second way to look at absolute value is think of them as like parentheses. Very similar to parentheses with that understanding of grouping, but then also attach that definition to it. Okay, so PEMDAS, we are going to utilize our parentheses first, aka the parentheses and the absolute value. And so I'm going to solve this 4 minus 1. And when we do, we get 3. I'm going to rewrite the rest of the problem. And then we're going to hone in on that second grouping, which is our parentheses. We have 8 minus 3 times 3, which is 9. And 8 minus 9 is -1. Again, rewriting the rest of the problem. Absolute value of -1 is +1. And then -2 times +1 is a -2. 4 minus 2 gives you your final results as 12. And we are done. So now we have a notes page, really highlighting our formal definition of absolute value. Distance away from 0, distance is always positive. And then we have the mathematical notation, and why don't we keep it as the same color? But this is our absolute value notation when it comes to mathematics. That absolute value of n represents both n and -n with these following ranges. Okay, distance, distance, distance can never be negative. Always going to shoot out a positive value when we're dealing with absolute value. And then this is just another way of expressing absolute value just from an equation perspective, where if we're looking at the absolute value of u, absolute value of u is a, well, that tells us that we have a negative case and a positive case. U could be -a or U could be +a. So this whole negative and positive case is really going to help us out for our future problems. So now let's take a look at example 1. We have absolute value of x is equal to 8. Well, we have a positive and we have a negative case. Our positive case tells us just drop the absolute value and our solution is 8. Our negative case tells us to drop the absolute value and then multiply that right-hand side by a -1. And we get -8. These are our two solutions. If we plugged this back into the original equation and solved, they would both work. And we're done. Let's look at B. B, we're asked to find what is our solution when the absolute value of y is -6. And that should really throw out a red flag for you because absolute value can never be negative, which tells us that we have no solution. Done. And then finally, we arrive at our part C, where we have the absolute value of z is equal to 0. So when we look at our positive case, we just drop the absolute value and our solution is z equals 0. For our negative case, we drop the absolute value and multiply that left-hand side by a -1. So we're looking at -0, and -0 is just 0. So our only solution is z is equal to 0 here, which tells us that we have just one solution. And we're done. So something to point out, we have absolute value always yields two possible solutions. And I should really add on to that. As long as the right-hand side is not negative. So this next slide talks about how to solve absolute value equations. And we have the step-by-step procedures, but we'll run through them together on our next slide. So in example 2, our first step is to always get your absolute value all alone. So we're going to go ahead and add 3 to both sides so that we're looking at the absolute value of 5x minus 4 is equal to 11. Good. Our second step is to look at your two cases. Your positive case and your negative case. So for our positive case, we just want to drop the absolute value symbols. And then you can solve for your x. And for your negative case, we once again drop the absolute value, but this time we need to multiply that left-hand side by a -1. So we're looking at -11. And then we solve. So now let's solve. What we can do is we can add 4 to both sides in both cases. That positive case, we end up getting 5x is equal to 15. That negative case, we get 5x is equal to negative 7. And then we're going to go ahead and divide both cases by 5. So our two potential solutions are x is equal to 3 and x is equal to negative 7 fifths. And then our final last step is we need to check to make sure both solutions work. So if we plug in 3 back in, we get 5 times 3 is 15. 15 minus 4 gives you 11. Absolute value of 11 is positive 11. 11 minus 3, does that give you 8? It does indeed. So that works. Negative 7 over 5 times 5, the 5's cancel out, so we have negative 7 minus 4, that gives us negative 11. Absolute value of that is positive 11 minus 3 also gives us 8. So both of them work, and we're good to go. Right, let's take a look at another example together. I wrote off our steps to the side here, but we're going to go through this a little quicker now. Isolate absolute value. So we're looking at 2 absolute value, x minus 7 is equal to 4. Still isolate absolute value. Let's divide both sides by 2. Absolute value of 7, or x minus 7, equals 2. Positive case, drop absolute value. Negative case, drop absolute value, and multiply right-hand side by a negative 1. And then solve. We'll go ahead and add 7 to both sides in both the negative and positive case. So our two potential solutions are x is equal to 9 and x is equal to 5. And then our very last step is to check to see if both of these work. Plug it back in. 9 minus 7 is 2. Absolute value of 2 is 2. Times 2 is 4 plus 5 is 9. This works. Let's plug in 5. 5 minus 7, negative 2. Absolute value of negative 2 is 2 times 2 is 4 plus 5 is 9. And they both work. So we're good to go. Let's jump into another example together. We're now on example 4. So I no longer have the steps off to the side. We should know them at this point. Get the absolute value all alone. So we're looking at absolute value of 2/3 x minus 4 is equal to negative 8. Positive case, we drop the absolute value. 2/3 x is the same as 2x over 3. So this is our positive case. Negative case, we drop the absolute value and then multiply that right-hand side by a negative 1. So now we're looking at a positive 8. And now let's solve. Let's add 4 to both sides in both the positive and negative cases. So we're looking at 2x over 3 is equal to negative 4. And we're looking at 2x over 3 is equal to 12. Then let's go ahead and multiply both sides by 3 so that the denominator cancels out. 3 over 3 is 1, 3 over 3 is 1. So we get 2x is equal to negative 12. And then we get 2x is equal to 36. And then our very last step is we're going to go ahead and divide both sides by 2. So our two potential solutions are x is equal to negative 6 and x is equal to 18. Now that we arrived here, we just need to make sure that both of these solutions work. So let's plug it back in. -6 times 2/3 is the same as, well, 3 goes into -6 -2 times. So that's the same as -4. -4 minus -4 is -8. And -8 absolute value of -8 is +8. And then we have plus 11 is 19. Just want to make sure that I did that correctly. Yeah, I did it correctly. So that does not work. Let's try 18, and it's not going to work either, but I'll show you. 3 goes into 18 6 times, and then we have 2 times 6 is 12. 12 minus 4 is 8. Absolute value of +8 is 8. Plus 11 does not give you 3. How did I know that that wasn't going to work? Well, we should have realized this at that very first step of the problem. When we subtracted 11 from both sides, that right-hand side became negative. What do we know about absolute value being equal to negative? It's impossible. Impossible for absolute value to yield a negative result. Therefore, no solution. So if you realize that in the beginning, then you just had to write what I have in black here, and you would have received full credit. If you didn't, you would have gone through the procedure just like we normally do, just like I did with you guys, and you would find that once you check your work, both solutions do not work. Okay. Now let's jump into equations with two absolute values. So you have one on the left-hand side and one on the right. Everything stays the same. You're still dealing with your positive case and your negative case, and then you're solving for your potential values. And you're probably asking yourself, well, there's two absolute values, so don't you have a positive case and negative case for this and a positive and negative for this? Yes, technically you do, but when you have a positive divided by a positive, that's a positive. Negative divided by a negative is a positive. And then positive divided by a negative and a negative divided by a positive are both negatives. So when you're dealing with these two different cases, positives and negatives, you're going to end up with two results. You're either going to deal with the positive case or the negative case. There's no other result. You can't have a neutral. It's either going to be positive or negative. So let's tackle this. Does not matter which side you decide to make the positive case and the negative case. Positive case, we just drop all of the absolute values, set them equal to each other. And then negative case, we drop all of the absolute values, and then we have to multiply one side by negative. Does not matter which side you're multiplying, you'll get the same result either way. And then we solve for our x. Let's combine some like terms. I'm going to go ahead and subtract 2x from both sides here and add 1 to both sides. So I'm looking at 3x is equal to 4, which tells me that one potential solution is 4/3. And then on that right-hand side, I need to utilize my distributive property. And then we can go ahead and combine like terms. So we're looking at 7x is equal to -2, which tells us that x is -2/7. And now we need to check to see if these solutions indeed work. We have 5 times 4/3 is 20/3. -1 is the same as -3/3, which is positive 17/3. Absolute value of this is just 17/3. Let's remember that. And then we have 2 times 4/3 is 8/3. Plus 3 is the same as plus 9/3, and that also gives us 17/3. Absolute value of that is still 17/3. So that solution works. Let's check to see if the negative case works. -2/7 times 5 is -10/7 minus 1 is the same as -7/7. So we're looking at -17/7. Absolute value is positive 17/7. Now let's go ahead and look at that right-hand side. -2 times, or -2/7 times 2 gives you a -4/7. Plus 3 is the same as plus 21/7. And then that also gives us 17/7. And the absolute value of that is 17/7. So this also works. And we're done. All right. Let's continue. So we're going on to example 6 in a moment. We just have a little notes page. When we're dealing with less than, what's happening? Well, if it's less than and we have our variable wedged between these two different values, we're just essentially dealing with that value being greater than that left-hand side, but less than that right-hand side. And so everything we learned about solving inequalities still holds, but we just have to consider how that absolute value impacts our work. Again, anytime you're dividing by a negative, we have to flip that inequality sign. So now let's look at example 6. And example 6, we're dealing with just x is less than 7. So no longer equal signs, we're now dealing with inequalities. I like to utilize this trick, less than, great or. If you have a less than inequality, then you're dealing with ends, you're dealing with intersections, you're dealing with, okay, what are the values shared between my two different solutions? Whereas if you were looking at great or, we are including everything. Of the two solutions, we're including both, and we're representing it on our number line and then showing what it looks like in interval notation. So let's again zoom in on this example. We have a positive case, and then we have a negative case. Our positive case, we just drop the absolute value. Negative case, we drop it and then multiply that right-hand side by a negative. And because it's less than, we're looking at intersection. All of the values that these two share, the overlap that is involved. And we can really clearly see it if we graph it on our number line. So we have a -7 and we have a +7. They're both open circles. And it's saying, okay, we're looking at all values that are less than 7. Maybe I'll use a different color here. All values that are less than 7. And then for the second case, also, one thing you want to keep in mind when you're dealing with inequalities and you multiply that right-hand side by a negative, what also happens is that inequality has to flip signs. And that's what I put over here. You don't want to forget that. So all values that are less than 7, but then greater than or equal to -7. So what's the overlap between the two? The purple and the green, which I have highlighted in blue right here. So to represent our solution in interval notation, we have all values between -7 and +7. And we are done. This is just a notes slide on solving absolute value inequalities from like a step-by-step procedure form. And again, when we're dealing with compound inequalities, we have a little bit more work to do before arriving at the solution. So let's take a look at this compound inequality. Positive case, leave as is. Negative case, multiply that right-hand side by a negative and flip that inequality sign. Now we can solve. I'm going to add 6 to both sides in both cases. And then what we can also do is we can divide both cases by 5. And so our two potential solutions, x is less than or equal to 2, and x is greater than or equal to 2/5. It's a less than, so we're looking at and, we're looking at intersection. Where's the overlap that's taking place? So let's graph this on a number line to really be able to see what's going on. We have 2 here and 2/5 here, and we're looking at all values that are less than or equal to 2. Make this like in a yellow. And shade all values to the left. And then all values that are greater than or equal to 2/5. Do that in a light purple. Shade all values to the right. So what's the overlap that's taking place? Our highlighted yellow. And so in interval notation, what does this look like? This looks like hard bracket, 2/5, all the way up to +2, hard bracket. And we are done. Easy enough. Okay. And then finally, our third objective. Now we'll look at some examples that involve greater than, which again, the nice little hint for this is great or. So we are including all values represented. When we have the absolute value of u is greater than a, then we're looking at all values where u is less than negative a, or all values where u is greater than a. Okay, same concept if you're dealing with greater than or equal to. So let's look at this example 8. Absolute value of x is greater than 4. Positive case, drop the absolute value. X is greater than 4. Negative case, drop the absolute value, multiply right-hand side by -1, and flip that inequality sign. And because it's or, we are looking at a union, finding all of the possible solutions. So when we graph this on a number line, we want to represent everything that's shaded. We have a -4, we have a +4. It's all less than or greater than, so we have some open circles. And so x is greater than 4, just shade to the right. And then we have x is less than -4, we shade to the left. We're representing everything. So in interval notation, this looks like all values from -infinity to -4, soft bracket, union, soft bracket 4, all the way up to +infinity. And we are done. Hence, or is linked with unions. And so this is the step-by-step procedure with solving absolute value inequalities with greater than or greater than or equal to. But again, we'll go through it nice and slowly as we jump into our compound inequalities. Inequalities that just essentially involve a few more steps. So, positive case, we have drop the absolute value. Negative case, we drop the absolute value, flip the inequality sign, and multiply that right-hand side by a negative. Now we're going to go ahead and solve. We'll add 3 to both sides in both cases to get one step closer to getting our x value all alone on that left-hand side. Then we're going to divide both sides by 2 so that the 2 different scenarios, x is greater than or equal to 4, or x is less than or equal to -1. Or stands for union, so we're looking at all possible values. Let's represent this on a number line. Because they're both underlined, we're going to have some closed circles here. X is greater than or equal to -4. Fill in the circle, all values greater than or equal. And then we have x is less than or equal to -1. Fill in the circle. And then we're going to shade in all values less than this. We're representing all of these, all of the yellow and all of the green. So in interval notation, what does this look like? This looks like all values from -infinity to -1, hard bracket, because we are including it. And because it's or, we have a union, hard bracket, +4, all the way up to +infinity, soft bracket. And we are done. So that does conclude our section 2.7. This was a little more on the complicated side, but the key is really taking it through step by step. Know your rules. Anytime you're looking at that negative case, you want to make sure that you are multiplying that right-hand side by a negative, and then you're also flipping the inequality. That's crucial in getting that correct solution in the end. Let me know if you have any questions, and have a great rest of your day. Take care.